Experimental precaution. Put only one magnet into the tray each time. There must not be any other magnets or metallic products around the tray, so they will not influence the outcome of the experiment. If we put two magnets like this, we can see that originally the N poles are facing right way, the S poles face left way. But now, the attraction of the two magnets will easily influence the outcome of the experiment. After putting the disc in the tray, we need to put the magnet down gently and try to put it in the middle. If it is placed at the side, water will get in. This way it will tilt to one side and make the experiment outcome false. If you put it down too hard, water will get in. Water may even spill over onto the desk. Pay attention to it as well. It is best to have dishcloth nearby to whip to prevent water spillage. Pay attention when using the circular magnet about the locations of the N and S pole of the circular magnet. The S pole of the circular magnet is on this side, the N pole is on this side. So do not leave it lying down. We will not get the experiment result in this way. So when placing it, it has to be standing. But when it is standing, it will roll all over the place. At this time, we can use the double-sided tape to stick the double-sided tape onto the magnet. If you think the double-sided tape is too big, you can cut it into a smaller piece. Just like this, we can stick it to the middle. Once it is done, the magnet can stand on the plate. Push it just a bit harder. If you're concerned that it may sink if you put it on while it is on water, you can take it to the desk. Once it is secured, just gently place it onto the water. Then we're going to use the U-shaped magnet. Earlier, when learning with the U-shaped magnet, all students know that the N pole is facing this way, the S pole is also facing this way, so students will think it is strange when they see this now. While the N pole and the S pole, the north and the south, are on the same side. This is the part that students often get confused about. So ask them to observe that most N poles face this direction and S poles face this direction. Actually, it has the same result as the bar magnet. Experimental precautions. Some of the paper clips saw today are made of plastic. They cannot be picked up by the magnet. Pay attention when we choose our paper clips. We have to choose the metal paper clips. When choosing the magnet to make a fishing rod, we have to choose a magnet that does not fall off easily. What do we mean by this? When we tie the magnet, we have to pay attention to the magnet's center of gravity. Like here, we will tie this at this position and not on the two sides. If it is tied here, the thread will slip off easily when we fish. The magnet will bump often, weakening its magnetic force. When tying the bar magnet, we will tie rope at the middle. We will tie the rope at the middle, which won't fall off as easily. We don't use the circular magnet often because it is difficult to, so we usually won't choose the circular magnet. Then we will choose the ring magnet. We can just pull it through the middle of the ring magnet and tie a knot. Like this way, it is quite convenient. You have to watch out when choosing the magnet and also pay attention to the place you tie. Experimental precautions. When we're choosing the magnet, the way to choose is to test with a non-magnet. We already know this side of the circular magnet is the N pole. This side is the S pole. So we will use it to do the test. Then we will know this is a single-sided magnet, which is something we can use. When we use magnets that we already know about to do the test, we will know that this magnet cannot be used. If we use an unknown magnet to do the test, we will see that these two magnets will also attract. It has the same result as the circular magnet we used just now. Then, when these two magnets are attracted together, you will find that the result of these two experiments are the same. It will not be easy for us to find out which magnet is the one we want. Now, we use this kind of magnet with its N pole and S pole on the same side and get close to the rotating paper doll. This kind of magnet cannot let the paper doll rotate, so we have to choose this kind of magnet. With a single-sided N pole or a single-sided S pole, get close to the paper doll by this magnet and then paper doll will rotate. When we're playing with the rotating paper doll, do not get the magnet too close to the paper doll. It will get attracted to it and won't be able to move. So we can keep a bit of distance from it, but cannot be too close. This way, it will be able to rotate and move. Experimental precautions. The first thing we have to pay attention is the way to gather the paper clips. Some people, in order to make it easier to gather the paper clips, will use the magnet to attract the paper clips. This will magnetize some of the paper clips. The paper clips with magnetic will influence the result of the experiment. Some circular magnets are quite special, like this one. It is a circular one-sided magnet. We will find that when the magnet gets close, only one of its sides will be attracted. Let us see it again. Here is the red N pole. Let us move forward to attract. We can see that it had only attracted half of the magnet. It is not like when we're attracting the circular magnet earlier, that the whole thing got drowned together. This kind of magnet is actually quite unique. Its N pole and S pole are actually on the same side. When we introduce the two poles of the magnet, we will introduce the bar magnet first. After introducing the bar magnet, students will usually know that the N pole and the S pole are at the two ends of the magnet. Then, what we will introduce next is the U-shaped magnet. Students will quickly know that the N pole and the S pole are at the two ends of the magnet. Only then would we introduce the circular magnet. Students will think that the N pole and the S pole of the circular magnet are on the two sides of the circular magnet. They will believe the N pole and the S pole are around the circle. All of these are the N pole and S poles, but in reality, the N pole and the S pole of the circular magnet are on two sides. The N pole is on whole side, and S pole is on this side. These two sides are its N pole and S pole. This is where students get mistaken often. By doing more experiments, we can let students know through the result of the experiment where the circular magnet's N pole and S pole are located. If the neodymium magnet falls onto a desk from high places, the neodymium magnet may crack. The broken pieces may cut our hands, so please be careful. We will lay a piece of cloth underneath to avoid such danger. Because the magnetic force of the neodymium magnet is very strong, it will easily attract many metal products. Please be careful when using it.